First and most importantly, I'm going to label first and last name on our tubes. My requisition sheet that is generated from a computer item, and we just want to fold that so that the barcode is showing. That's the first thing the lab will use. Also, I'm going to put the number 2 and my initials, JZ. That means we've got 2 items going out to the reference lab, and that makes sure that we have everything in there. So this is ready to refrigerate. So whenever we are going to run our first sample of the day, we go through removing the machine from standby cycle, doing a background check, and then I have a control that I'll be running as well to ensure the machine picks up the correct parameters. So first I'm going to go ahead and start my background check with no sample at all. I'm just going to press start. So our background check has finished running, and I'm just going to compare our values. So red blood cells should be equal or less than 0.03, and our red blood cells right here are 0. White blood cells should be less than 0.2, and those are 0. Hemoglobin should be less than 0.2, that's 0 as well. And platelets are 0, which is within our range of less than or equal to 10. The first thing I want to check with my control is that it's not expired and it is stable for 16 days. And then, so I've run my background check. The next thing I'm going to do is run my control. So run that, and I want to make sure that my lot number matches. 1170472, that's correct. So I'm going to wipe my sample probe before adding my sample. Then I'm just going to remove the cap, add my sample, and press the start plate. Then I can replace that. And I don't wipe the sample probe after adding my sample because this machine uses that as part of the sample. So as soon as that's done, which should be here shortly, we'll go ahead and check our reference values. Now that my control has run, I'm going to run through and make sure that my results here match my range limits here. White blood cells are 8.5, so that falls within our limits. Hematocrit is 28.5, we're good there. MCV 74.4, we're good there. Red blood cells 3.82. Hemoglobin is 10.5, we're good. MCHC 37, good. And platelets 175, so all of our values match. So our control is good, and we are ready to run our sample. I've got a snap test for Parvo. This has been hanging out at room temperature for a little bit, so we're not refrigerated anymore. I'm just going to take the swab out. Get a little fecal sample. Snap the top. So we're good to go. We can put all those in. Drop my sample into the sample well, and I'm just going to watch for this to reach my little indicator window. I'll snap down the back of this to activate the test, make sure it's all the way snapped, and then we've got 8 minutes to read our result. Alright, so our test is now complete. Our 8 minutes is up. So we've got our strong control dot at the top, and then any other dots besides this positive control mean that we're positive for something. This test only tests for one thing, which is parvo, so we do have a weak positive over here on the right side. So this dog is testing positive for parvovirus. So first I'm going to get some ear swabs on this kiddo here. So I'm just going to kind of go along the outer edge of the ear, make sure I can get a good sample. Okay, there's my left, and then I want to be able to identify these, so I break the left one. Everybody's a little different. And I'm going to do the same thing on the right side. Alright, and next we're going to stain these and look at them under the microscope. Next I'm going to rub my ear sample on a microscope slide. So I'm going to make a nice square. I prefer to do the left kind of by the frosted side, and then a square with my right ear sample. So I've got two nice squares, and then the way I just remember that is frosted and like you're reading a book left to right, so left and right. Next I'm going to heat fix these a little bit to kind of melt the earwax. So then I'm going to stain these, and I've got my Diff Quick solutions here. The first one's fixative, and then we've got a red stain, purple counter stain. So I like to run water in the bottom of the sink just so I don't stain up the sink. Got some distilled water that I'll rinse my slides in. Alright, the next thing I'm going to do is kind of blot the excess moisture off of my slide. And we are ready to examine this under a microscope. We'll start on low power. I'm going to find a kind of a corner of my sample. I'll move up to 10, focus again. And then when I move to my oil objective, I'm going to take a little immersion oil. And then I'm just going to scan this in a routine pattern. Adjusting the fine focus as I go. Right now, not seeing a whole lot. A little bit of debris, some epithelial cells. Things I'm looking for on the ear cytology include yeast and a couple different types of bacteria. So I can look for cocci and rod-shaped bacteria. Right now just seeing a little bit of debris and some cells. Yeast are going to kind of resemble like a snowman or a bowling pin or a peanut. There's different ways to remember what they look like. Cocci are going to be tiny round dots, usually in pairs or sets of 4. And rod-shaped bacteria are pretty distinct. They're just going to be, I think they almost resemble tiny yeast. And I'm going to look more where I see more of the debris on my sample or cells, because my bacteria and yeast are going to kind of be close to those areas. Yeast are going to be the most common finding with ears. There's one budding yeast. And then when I'm done scanning left ear, I'm going to move over to my right side. So on the left side I would just say like occasional yeast. if I were to see bacteria or more yeast, I'd say I try to quantify, 0 to 1 per high-powered field, 2 plus, 3 plus, 4 plus. If there's a lot, I would say too numerous to count. So I'm not really seeing anything on this right side. Now I'm going to demonstrate how to set up for a necropsy in the hospital. First of all, I want an area that will prevent leaks and spills. Typically we'll do this inside of a trash bag. This has a little bit of absorbency to it as well. So I'm going to lay this out first. This is going to be a very small specimen that we're performing our necropsy on. And then as far as my supplies, I've got scalpel blade holder, scalpel blade, tissue forceps, pair of scissors. These are nuts and bombs. For a larger animal, I might use a braiding scissor or Mayo scissors. And then I've got some needle holders and some suture. So this is to put everything back together whenever we're done with our necropsy. And this is a really good application for like expired suture or suture that's open that we can't use for a sterile procedure. Then I've got some formalin jars. I've got different sizes here, and some gauze, and then our PPE. So when we're working with necropsies, we are looking for a cause of death, which means we're not really sure if it is infectious or zoonotic. So we want to take all precautions to ensure our safety as well as prevent contamination from the specimen we're working on to other patients that we may have in the hospital. So I've got a mask and gloves and a gown, and I have this for my clinician as well. So I'm going to go and start by putting on my PPE. And then something I'll remember is that all the specimens that I use need to be labeled. So I'm going to have my Sharpie out as well, and a pen in case I need to take notes. And anything I use, I want to make sure is fully disinfected after using. And then I just want to label my jars. So I'm going to put the patient's first and last name on here. And then if I'm sending multiple samples to the lab, I want to label where the specimens came from as well.
Okay, Jenneth, we're going to get a couple different samples here so we can look for some pathology. So we're going to basically get some histopathology done on the liver and anything else that looks suspicious. So I need your help with that.
Absolutely.
So we're just going to real gently go through here to make sure we don't damage any of the organs inside. So this is a liver sample we're going to take here.
This is a formalin jar. I don't want to inhale these vapors. I don't want to splash this in anybody's eyes. And I'm going to close that directly afterwards.
Actually, I think what we'll do, Jenneth, is we're actually going to get a sample of lung tissue as well. I think that's the other target organ. But this will be interesting to see. Great, thank you.
So rabies is a viral disease of warm-blooded animals, mammals, that is pretty much always fatal once symptoms develop. So when we have an animal whose vaccination status is unknown, or maybe it's a stray or an owned animal or wildlife. Then we have certain precautions that we'll take if we suspect that another pet or a person may have been exposed to rabies. Rabies testing in the state of Colorado is only performed at the Colorado Department of Public Health laboratory. When we send samples to that lab, we want to make sure they're in leak-proof containers. So we're just sending the head, typically for a small animal, whole bat, or samples from a large animal brain. It should be refrigerated for this particular lab. Other labs will specify that they want the sample frozen or shipped on dry ice. So it's important to review the laboratory's directions. You have to wear proper protective equipment, including like a face shield or eyeglasses, protective mask, gown, and shoe covers, as well as gloves. And make sure to properly disinfect anything with a 10% bleach solution that's freshly made. If we have a pet that maybe was bitten by a stray dog, or we think may have been exposed to a potentially rabid animal, we'll do a quarantine of 10 days. Only people that have been pre-exposure vaccinated against rabies should handle this animal if at all possible. Typically we'll use a restraint pole to put distance between the pet and people handling the pet. The pet should be kept in a closed-top kennel. We have to keep a log of every person that handles that animal, and then all of the food dishes and bedding needs to be labeled, washed separately and bleached. After submitting sample, the rest of the body should be incinerated typically, so we'll double back that and clearly label rabies suspect on that. I'm going to demonstrate how to do a vaginal cytology. We've got an intact female standard poodle here. I'm going to take my Q-tips and moisten this with a little water. Alright, so one important step that I missed on my previous video is that I just need to wash this area first before doing our cytology. So I'm going to treat this similar to like a surgical prep area, and I'm going to go from the center out and not overlap. And I want to do at least 3 good scrubs before I begin. We're going to start by going straight up. Okay, almost done.
You're fine.
Then I'm just going to kind of roll back and forth a little bit, pick up some of the cells, and come back out. Alright, there's my sample. So take a clean glass slide and just kind of roll that sample on there. And then we'll go stain this and look at it under the microscope. Alright, the next step in our process is we're going to stain this and look at it under the microscope. So I've got my labeled slide here. Step of our process is to view the cells under the microscope to determine our stage of estrus. So I'm going to focus and find kind of a good corner of our sample using the lowest power focus, which is our 4x. I'm going to switch over to our 10. Focus again, and then I'm going to view this whole thing under our 40 power. That gives me a good view of where the cells are at
I can determine whether or not they're cornified, or if they have their nucleus, and kind of get a good idea of our percentage of cornified cells. So as I'm viewing this, I'm looking for a couple different things. I'm going to look for some clumps of cells. Okay, so there's some good clumps of cells right there, and they all appear to have their nucleus. I'm not seeing any red blood cells. I'm not really seeing any white blood cells either, and I've got another really good clump of cells here. And they all have like their nucleus, it's clearly discernible. When we're looking for cornified cells, we're going to see that nucleus start to fade. And kind of a good way to remember what that looks like is the cells kind of resemble cornflakes, like they're just laid flat. This bitch is an anestrus, which is not fertile right now. The next stage in our cycle would be proestrus, so I'd start to see a lot of red blood cells. And then as the red blood cells fade and we start to get more cornified cells, we're approaching estrus, and we've got a high percentage of cornified cells. All of these look like they have their nucleus intact. So then we have estrus, so we've got a high percentage of cornified cells, and we can't clearly identify those nuclei, they're not very prominent. After that, after we ovulate, we're going to start to see more red blood cells again, and we're also going to see white blood cells, and that tells us that we're in diestrus. And then we just repeat our cycle. So I've got our samples from our donor. So I've got an EDT, lavender top tube, and a serum separator tube. And then for our recipient, which is Blaze, I've got the same thing. The first thing I'm going to do is I'm going to go ahead and spin those down. Our blood setting is 3,400 RPM. I'm going to spin that about 5 minutes. Now that I have my packed red blood cells and I've removed the plasma from these tubes, I'm going to start my cell washes. I've got Rue as my recipient, so I'm just going to add a couple of drops of the packed red blood cells. And then I fill the rest of this tube with some saline. Alright, and I got this labeled, so this is my recipient, and then I'm going to do the same thing with the donor. So I got my two labeled tubes here. I'm going to spin these down for a minute at my blood setting, which is 3,400 RPM. Alright, my first wash is complete. So I'm going to remove the supernate from this tube and just leave the red blood cells. I'm going to add more saline and I'm going to repeat my wash a second time. Now my second wash is complete. So as you can see, my supernate is a little clearer than it was for the first watch. And we're going to do one final spin. Now our packed blood cells are done washing, as long as my supernate is clear, which it is. So I've got the donor cells here, and I'm going to get rid of all the supernate. Got a tube for my cell suspension. I just need 0.02 mLs of packed blood cells. This is going to go on my labeled tube. And then I'm going to take some saline. So I just need 0.98 to make a 1 ml total suspension. And I'm going to add that to my packed blood cells. Do the same thing with the recipient. Once again, the supernate is nice and clear. Add 0.98 mLs of saline. Alright, so there's my cell suspension. Next I'm going to start doing my actual cross matching. So I've got two control type tubes. So what I'm going to do is I'm going to take 2 drops of this packed red blood cell suspension and 2 drops of serum that I have spun down. So I've got my recipient and my donor. So in the recipient control, I'm going to add 2 drops of the recipient's serum. 2 drops of cell suspension. And there's my recipient control. Next I'll make my donor control. Same thing, it's going to be 2 drops of donor serum and 2 drops of donor cell suspension. Next I'll do my cross matches. So I've got my minor cross match. The minor cross match is going to be the recipient cell suspension mixed with the donor serum. Alright, and then I'll do my major cross match, which is the donor cells and the recipient serum. Next, I'm going to let these incubate at room temperature for 30 minutes, and then I'll come back and take a look at them. Alright, so our tubes have been incubating for about half an hour. We're going to go ahead and centrifuge these. So 3,400 RPM per minute. Alright, my tubes are done spinning. Alright, so it looks like the supernate is still nice and clear on all of those, so that's good. That means I don't have like a significant hemolysis. So next I'm going to check for macroscopic agglutination. I'm just going to remix these and look to see. Usually I'll get kind of like a sandy appearance of the red blood cells if I see them sticking together. Step is to make a slide of each of these and check for microscopic agglutination. I'm going to label these 4 slides: donor control, recipient control, minor, cross-match, and major cross-match. Next, I'm going to bring these over and look at them under the microscope. So I'll check my controls first, because if my controls show autoagglutination, then I have to throw them out because they're not going to give me a reliable result. I'm looking at a nice even layer of cells. Some of them are crenated, and that's a normal finding. I'm not really seeing any abnormalities here. Like, I've just got a nice even layer of cells, so we're not sticking together. Very mild crenation. So again, that's normal. So next we'll look at our cross matches. I'm not seeing any abnormalities, just a nice even sheet of red blood cells. And then my major. Not seeing any agglutination, just some moderate crenation. If I were using this to determine whether or not these 2 pets were suitable for a transfusion, then I would not find abnormalities here. So our planned transfusion is good to go. So the purpose of this video, I'm just going to choose an area. I'm going to kind of squeeze the skin. That helps get me a more diagnostic sample. And then I'm just going to take my scalpel blade. I'm just going to scrape across the surface of the skin. And I want to get a little bit of capillary bleeding to indicate that I've got a good diagnostic sample. I'm just going to take my glass slide and apply to those skin cells that I've got. And this is ready to read. So I've got my sample, and I'm just going to cover this with a cover slip. And I'll look for mites under the microscope. I'm going to start on my 4-power objective. I'll turn my light source down so I don't blind myself. And I'm going to kind of focus on some of the skin cells that I can see.
And I'll probably just do a real quick scan of this cover slip and see if I can catch any obvious mites. There's two main mites that I'm looking for. Those are going to be scabies, sarcoptic mange, and demodectic mange. Scabies is harder to spot because they tend to burrow deeper into the skin. So I'm seeing several hairs on here and some debris. And then I'll go back over this on my 10 power one more time. So I'm systematically scanning. I'm going to focus on kind of my debris. I've got my hand on the focus so that I can readjust constantly. So a negative skin scraping doesn't necessarily mean that we have a dog that does not have mites. It simply means that we didn't get a confirmation that we do have mites. So there are multiple things that can cause skin disease and hair loss. And if we can isolate mites on a skin scraping sample, then that's a pretty straightforward fix. Demodectic mange have a genetic component to them, so those tend to stay with the dog its whole life. We can manage outbreaks of hair loss and overpopulation of mites, but in times of stress, those tend to come back. Some of the newer flea and tick medications have shown some efficacy against skin mites. So that's been very helpful. And I'm not seeing any types of skin mites on this slide. Scabies, on the other hand, is the one that tends to burrow deeper and is harder to isolate on skin scraping. It does have zoonotic potential. Humans are a primary host, but it can still cause us to itch, and scabies is extremely itchy.